I would like you to walk us through the passages from working in the field in the outcrops to dedicate yourself to the stress strain and then moving into experiments.
The first part was just field work, making maps, getting them right and trying to interpret them. And then the question is, what moved me from that, or even just writing about that sort of approach, to the more quantitative? I guess it was the feeling that I myself was too ignorant on that front. So I had to try to get better at it. And luckily, being a professor, you have a good deal of time to yourself to work on a project like that. I needed to get better at it and then explain it to other people. Well, you know, I got interested in experiments first when I was in New Zealand in the early 60s. I remember the chemistry department down the hall, and I started doing something we thought was quite new, and that is making cylinders of reactants, chemicals, that would, under temperature, form new minerals. And we wanted to see what happens if you form new minerals while that cylinder is being shortened, being squeezed, not just static, but while it's changing shape overall. So I did a little of that in New Zealand with John Rogers. Then I went to Australia with Mervyn Patterson, who was a famous rock deformation experimentalist, and did some similar work with him. But I realized that the trouble with all of these was you couldn't see what's happening on the scale of the individual grains during the squeezing, during the reactions. So I thought, let's just, and the two of us thought of this at about the same time. Janos Jure in Utrecht and me in Albany. Let's make a thin film and devise a way of at once squeezing it and watching it with a microscope and seeing what the grains are doing. The impetus was just to make a new kind of observation, sort of like the impetus for going to the moon and bringing back some samples. What's it made of? What's there? What are the facts? So that was the idea in those experiments, which did occupy me a lot in the 70s and 80s. A new way of learning about microstructure. And it may end up not being much use, or maybe a lot of use even to people outside of geology, to metallurgists, to ceramicists and other people interested in how to make materials stronger, let's say. How do you make them strong? What's going on inside them that you can watch and use to engineer stronger materials? I'm being a bit optimistic about that. It may never catch on or be useful, even in those fields, but could be.